Hey, magandang buhay! So ako si Sir Ben at narito ako upang ituro sa iyo paano nga ba mag-prove ng trigonometric identities. Okay? So let us start with the first example. So we have here cotangent A plus 1 is equivalent to cosecant A times the quantity of cosine A plus sine A. Our goal in proving trigonometric identities is that the expression on the left side must be equal to the expression on the right side. So we can show that one with the use of the property, the reflexive property of equality. The reflexive property of equality is saying that whatever you see on the left side of the equation must be the same with the one that you will see on the right side of the equation. Okay? So, in proving trigonometric identities, it's up to you what you want to manipulate. If you want to manipulate the left side of the equation or the right side of the equation. Okay? It's up to you. But I suggest that you manipulate the side of the equation that is more complicated. Okay? Then another thing is that when we prove trigonometric identities, we should express the expression in terms of sine and cosine functions only. Okay? So, in this example, what am I going to manipulate is the one on the left side. Okay? So, cotangent A plus 1. The one on the right side, I'm not going to manipulate that one. Cotangent A plus 1, what am I going to do here is to express cotangent A plus 1 in terms of sine and cosine. So, cotangent A now will become cosine A over sine A by applying the quotient identities. Okay? So, it's very important that we know or we memorize the fundamental identities. These are the reciprocal identities, the quotient identities, and the Pythagorean identities. Next, we add cosine A over sine A plus 1. So, it will become cosine A over A plus sine over A. We can merge those two fractions. So, it will become cosine A plus sine A all over sine A. Again, our goal here is the expression on the right side of the equation and the expression on the left side of the equation must be the same. Okay. Next is I'm going to factor out 1 over sine A on the left side of the equation. So it will become 1 over sine A times cosine A plus sine A. Next is that we know by applying reciprocal identities that 1 over sine A is equivalent to cosecant A. As you can see now, the one on the left side is equal. It's the same with the one on the right side of the equation. I'm going to show you same given, but I'm going to show you another way of proving that these two are equal. Okay, so in this case, what am I going to do is to manipulate the one on the right side. Isn't it that on this part of your screen, I manipulated cotangent A plus 1. In this second example with the same given, I'm going to manipulate the one on the right side. Okay, so what am I going to do here is cosecant A, I'm going to express it in terms of sine and cosine function only. So, cosecant A now will become 1 over sine A. And that is applying the reciprocal identities. Next, I'm going to distribute 1 over sine A to cosine A and sine A, as you can see on our screen. Next is that I'm going to convert cosine A over sine A into cotangent A by applying the quotient identities, while sine A over A, that can be simplified into 1. Okay? So, as you can see now, the one on the left side is the same with the one on the right side. So you can see here, it's up to you how are you going to prove the given identities. Okay? So, there's no one way in, there is no one way in achieving our goal here. Let's proceed to the second example. So we have here sine cube x is equal to sine x minus sine x cosine squared x. So as you can see here, the one on the right side is more complicated compared to the one on the right side, which is sine cube x only. So in this case, what am I going to do is we don't need to express this in terms of sine and cosine because it's already expressed in that manner. So what am I going to do here is to factor out sine x. So it's very important that we know the factoring, we know how to add fractions, okay? We know how to multiply special products, so on and so forth, okay? Next is that when we apply the Pythagorean identities, this will now be equal to sine squared x. What we used here is the first identity under the Pythagorean identity. So that is sine squared x plus cosine squared x is equivalent to 1. Next, multiply these two and we will achieve sine cube x. And that's it. Okay, so we already showed that sine cube x is equal to sine x minus sine x cosine squared x. Third example, so we have here cosecant b minus sine b is equivalent to cotangent b, cosine b times cotangent b. So in this case, I want to manipulate the one on the left side. So express that side of the equation in terms of sine and cosine function only. So cosecant b will become 1 over sine b, okay, by applying the reciprocal identity. Next is we're going to subtract. So what am I going to do here is to express sine b into another form. So sine b will be now sine squared b over sine b. Why? I want to make these two terms as a similar fractions. Okay? Now we can now merge these two fractions. So this will be now 1 minus sine squared b all over sine b. So 1 minus sine squared b is actually equivalent to cosine squared b. No? So that is the first identity under the Pythagorean identity. Just like what I did here, okay, in this part. No? Next, cosine squared b can be written as cosine b times cosine b. Just like 3 squared. 3 squared can be written as 3 times 3, correct? So in that case, this will be now cosine b times cosine b over sine b. And simplifying cosine b over sine b, this can be written as cotangent b. Okay? So applying the quotient identity. So in that case, we already showed that cosecant b minus sine b is equivalent to cosine b cotangent b. Okay? Next, fourth example. So we have here secant theta plus tangent theta is equal to 1 over secant theta minus tangent theta. So in this specific example, I'm going to manipulate the one on the right side of the equation. Okay, so as you can see, it's very obvious that 1 over secant theta minus tangent theta is more complicated, simply because it is in the fraction form compared to secant theta plus tangent theta. So what am I going to do here is to express the right side of the equation in terms of cosine and sine functions only. So secant theta will become 1 over cosine theta and tangent theta will become sine theta over cosine theta. Next, we can merge these two fractions. This will become 1 minus sine theta over cosine theta. Next, this one will become cosine theta over 1 minus sine theta. What's the reason why I converted this complex fraction into this fraction? Okay, so personally, when I encounter a complex fraction, I convert it into a division sentence, as you can see on our screen. And then we all know that when we divide by fractions, what we do is we reciprocate the second fraction and then proceed to multiplication. So that is the reason why 1 over 1 minus sine theta all over cosine theta is equivalent to cosine theta over 1 minus sine theta. Next, what am I going to do here is that, okay, observe the one on the right. I don't want to manipulate the left side, but you can do that one. Okay, but in this example, I want to stick with manipulating the right side of the equation only. So, the one on the right side of the equation, we cannot do anything. Why? It's already the simplest form. We cannot factor anything. It is already expressed in terms of sine and cosine. So, the thing here, the next thing to do is we can multiply something that it won't change its value. And that something will be 1 plus sine theta all over 1 plus sine theta. Okay? Sir Ben, why is that it won't change the value, or it won't change, multiplying that to 1 will not change the value of cosine theta over 1 minus sine theta? Simply because this is equivalent to 1. If we multiply a number by 1, still the same number. Okay? Next, how are we going to identify if we will do this one, or how are we going to identify if that is the expression that we must multiply for us to finish the task here? So in that case, it's more on familiarizing yourself, it's more on exposing yourself. Okay, so through exposure, through familiarizing yourself in proving trigonometric identities, you can easily identify that that must be the expression to multiply to the given expression. Okay, so that is through practice. There's no formula here, there's no shortcut here, so there's no what we call technique. Okay, so you need to familiarize, you need to expose yourself with this type of exercises. Next, what am I going to do now is to multiply this. So, the one on the numerator will become cosine theta times the quantity of 1 plus sine theta, while the one on the denominator, it will become 1 squared minus sine squared theta. So, that is actually special product. So, that is the product of the sum and difference of two terms. Next, our denominator can be converted into cosine squared theta. Next, we can cancel out cosine theta and cosine squared theta. Now, our numerator now will become 1 plus sine theta only, while our denominator will become cosine theta only. Next, we can rewrite that one into two fractions. So, it will become 1 over cosine theta plus sine theta over cosine theta. And we can now convert this one. 1 over cosine theta is actually secant theta by reciprocal identity. And sine theta over cosine theta is actually tangent theta. That is by quotient identity. Down to our last example. So we have here the quantity of cotangent x minus cosecant x squared is equivalent to 1 minus cosine x all over 1 plus cosine x. Say for example, Sir Ben, on the right side of the equation, we cannot do anything simply because first, it's already expressed in terms of sine and cosine. Yes, you're correct. It's already in the lowest term. Yes, you are correct. So what am I going to do here, Sir Ben, is I am going to manipulate the left side of the equation. Well, we don't have, yes, that's okay with me. But if you will manipulate the one on the left side of the equation, so that is a binomial, right? So if you will square a binomial, it will become a trinomial. So instead of simplifying it, okay, you are making it a bit more complicated. From binomial, from having two terms only, you're making it you're making that expression into three terms. So from simple to more complicated. So what am I going to do here is I'm just going to manipulate the one on the right side. How? I'm going to multiply something that won't change the value of 1 minus cosine x over 1 plus cosine x. And that will be 1 minus cosine x all over 1 minus cosine x. The question here is, why is that why is that the expression 1 minus cosine x over 1 minus cosine x must be multiplied to the expression on the right side of the equation? Exposure, familiarization. Okay, so you need to expose yourself. There are a lot of examples in YouTube, in the internet, or in some books, or in some ebooks. There are a lot of examples that you can practice with this topic. Okay, next, what we can do here is that we can now multiply the 1 on the numerator. That will become the quantity of 1 minus cosine x squared. Our denominator, it will become 1 squared minus cosine squared x. Next, our denominator now will become sine squared x. Next thing to do here is that we know that sine squared x can also be written as sine x raised to 2, or the quantity of sine x squared. And applying a loss of exponents, we can rewrite this as 1 minus, or the quantity of 1 minus cosine x all over sine x squared, as you can see on our screen. Now, we can, as you can see here, isn't it that the one on the left side is a quantity squared, while on the right side, it's now a quantity squared. So we achieve the exponent 2. So what we're going to manipulate now is the base. Okay, this one. So we need to make sure that this one will be equal to cotangent x minus cosecant x. What we're going to do now is to separate these two. So we can rewrite this fraction into two fractions. So that will become 1 over sine x minus cosine x over sine x. Next is, we can now convert this into cosecant x, applying the reciprocal identities, while this one can also be rewritten as cotangent x, applying the quotient identities. Now, Sir Ben, the two is not equal simply because cotangent x minus cosecant x is not the same as cosecant x minus cotangent x. We all know, Sir Ben, that what do you call this? The commutative property is not applicable in subtraction. Yes, you are correct. So, what should we do here right now? What we will do here is we can now manipulate both sides of the equation. Okay? So, we can square this part of the equation and also the right side of the equation, as you can see on our screen. Now, Sir Ben, they're not exactly the same. Yes, you are correct. They are not exactly the same, but what we can observe here is that we can actually interchange the position of those two functions that are being written in the red ink. So we can interchange them simply because they are both positive, or yes, they are both positive, and we are simply adding those two. So by applying the commutative property of addition, we can interchange them. Another thing is that the thing that you will see that is written in blue ink and green ink can also be interchanged by applying the commutative property of multiplication, right? And as you can see now, the one on the left side is exactly the same with the one on the right side of the equation. Okay? So that's how we prove trigonometric identities. So it is very important that you memorize the fundamental identities. You need to expose yourself so that you would be familiar with the different techniques. In doing this one, you must choose which side to manipulate. It's up to you if you want to do the right side or the left side. I may suggest that you must do the more complicated side, and then you must express, okay, the expression in terms of sine and cosine functions only. Always remember this one, that you might prove the identities in fewer steps compared to your classmates that he or she did it for more steps than you did. So it means that there is no one way in achieving the goal here. Okay? So practice, expose. Okay? So that's the only secret in proving trigonometric identities. And with that, maraming salamat sa pakikinig and magandang buhay.